It's also maybe for the good as well.
We will see. But I am here to introduce our speaker. Our speaker is Andy Connolly. He is an educator at the Natural History Museum of Utah. After getting his master's studying Mosasaurs at the University of Kansas, he worked as a seasonal ranger at Fossil Butte National Monument and Grand Teton National Park before moving on to the NHMU in 2019. He is part of the Museum on the Move program, which involves visiting public schools across Utah and teaching the natural sciences to elementary students. And his talk today is going to be called From the Field to the Classroom: How to Inspire a New Generation of Paleontology Detectives Through Inquiry-Based Learning. Take it away, Andy.
All right, thank you very much, Carrie, and thank you for introducing me. Carrie actually came to me a couple of years ago when I started working, and she said, well, you know, we have this meeting. If you ever want to give a talk, just let me know. And I thought, well, I don't know really what I could say exactly. And then last month I thought, would education be fine? That's kind of like my bread and butter, something I'm passionate in. And she said, yeah, go for it. So I'm really happy to talk about this. So let's see. I'm going to, Okay, so hello everyone. Sorry about that. So yes, like Carrie said, I am an educator at the Natural History Museum of Utah, and let's do a little background on who I am. So I got my master's in geology at the University of Kansas in 2016. I then became a park ranger at Fossil Butte, followed shortly after at Grand Teton National Park, where I began to really curtail my education. And what's funny is that when I was a kid, I loved paleontology. I still love paleontology. And I had this big overall idea of being a professor at some university or museum. So when I was getting my master's in geology, I quickly realized that this wasn't probably the path for me, but I actually found out that I had a love of teaching when I became a GTA. And so I kind of started going down that path of really honing in my education, my teaching, and just expanding the opportunities of reaching out to different audiences. And so then I started working at the Natural History Museum on September 2019. And what I do is, like Carrie said, I visit different public schools and we teach a variety of topics, mainly adaptations, fossils, archaeology, things like that. So for today, well, the first thing I want to talk about is learning environments. There are many different kinds of learning environments when we are creating a presentation, when we are creating whatever that may be, focus on fossils, animals, artifacts, things like that. So when we're creating our program, when we're creating our class, it's good to keep in mind what kind of audience are we reaching out to? And what kind of setting is this? There's a terminology used a lot called formal versus informal. Formal spaces in learning include things that have a set time, a set schedule, where you have a captive audience, an audience that has to be there for whatever reason, whether it's a classroom, they're doing a guided program, they want to show up for the guided program and want to stay there to the end, or maybe a campground version of that, like a summer camp. An informal space, on the other hand, is a lot more loose, and there's a lot more back and forth between the presenter and the audience. And this can be anything from being on the trail, being on the front desk, or what we call pop-up programs, where we bring different kinds of items, like skulls, for instance, to a random point, and then we meet with different visitors or audience members, and these informal spaces can last as short as 20 seconds to even much longer, to 5 or 10 minutes even. In my case, for the rest of this presentation, to make sure we're all on the same page, I'm going to be focusing mainly on a classroom environment focused primarily towards children. That is to say, though, that the things that I'll talk about today, are just restricted to those audience members. You can also apply it to the different spaces and the audiences as well. But I'm mainly going to be pulling examples from these two spaces when we're talking about what makes an effective educator and a learning environment. So the first thing that you want to think about is knowing your audience. And particularly for age, ensuring that your audience understands and connects with the material is very key to communicate your ideas. There's this thought process that sometimes when I talk to experts, they may throw around a phrase like dumbing down. Like, I got to talk to children and I have this very complicated topic and I just got to dumb it down for them. Unfortunately, that is not a good mindset to put yourself in, because that can potentially limit your reaching out and connection with your audience members. And that could potentially be gatekeeping. You're expecting your audience to know certain things, and because they don't know certain things, you're not even going to bother with it. Instead of thinking of it as dumbing down, think more of it as interpreting, as translating it. You may have a complex idea, but you can translate it depending on who is listening. And there's this great YouTube series that has different experts. In this case, the example I have here is an astrophysicist who explains the concept of gravity to different members: a child, teenager, college student, grad student, and an expert. And I highly encourage you all, when you have the time, to check out these videos because they're very interesting. It's to see these experts being able to passionately talk about their topic to children, and the children can ask them really good questions. And to hear them talk about these rather complex topics is very awe-inspiring. So definitely think of it in a way as when you have an interesting fact or an idea, translate it in a way that all audiences can take away something meaningful from it. So what makes an effective educator? So there's these two phrases that you may have heard of before: sage on the stage versus guide on the side. Sage on the stage is what we would traditionally call like a traditional classroom setup. You have an expert, like a teacher or a professor, who stands in the front of the classroom, has a PowerPoint presentation or writes on the whiteboard, and the audience sits there, passively takes it in with minimum interactions. For the sage on the stage, this can be pretty great when the audience has zero or little knowledge or experience in the subject on hand. However, the problem with being the sage on the stage is that the audience are what we call passive learners. They are taking a passive role. It is the educator, is the expert who is mainly doing the actions, the teaching, while the students are sitting there taking it in. The issue of this is that this form of education doesn't always work well for your audiences. And a lot of times, many key ideas or principles may get lost or not fully developed within their psyche. That is why guide on the side is a great way to approach teaching and education in the classrooms. In this case, the instructor takes the role of a facilitator and more motivates and guides the audience. The audience is an active participant. When they are learning about the subject, they're taking it in their own hands. They're reading about the material. They're observing the specimens. They are experimenting, learning through trial and error. And whenever they get off too much of the path, the facilitator can guide them back on and help them right their direction, so to speak. In this case, the audience is able to reconstruct the information into a more meaningful way and is more likely to remember it. Trade-off being is that this environment can be chaotic. When you have the traditional sage on the stage, you have a very set time of, I'm going to talk about this for this long, and topic B for this long, and so forth. But being on the guide on the side, the students are in control of the time. They are the ones that are learning it through their own processes. And as such, it can be very messy, just as like in the real world. Here's the thing though, is that the guide on the side may be effective for an audience to more take in the information more meaningfully. But you don't have to immediately dissuade sage on the stage. A combination of both can be very valid in the classroom. If the audience, for instance, doesn't know anything about trilobites, you can talk to them about trilobites for, say, 10 minutes or so. How old were they? What were they like? Things like that. And then introduce an activity for them to learn about trilobites, them researching and observing the specimens through their own means. This leads to inquiry-based learning. Inquiry-based learning is a fantastic way of facilitating learning in this environment. Simply, students engage in a scientific phenomenon or an observable event. And they do this by asking questions, they research the material, they create their thoughts, they share their results, and they reflect. I have this little guide, this diagram on the right here. And honestly, I think it's great. I think it's fine. I think it's a little bit too simple though. Honestly, I would just put arrows pointing all over the place. Because when I'm in that environment, sometimes students will jump back and forth between their thought processes. They're sharing, they're learning, they make mistakes. What do? They investigate even further. They create new thoughts, new ideas. They ask new questions. In this process, this is where that chaos comes in. But it's really wonderful to see that in action, to see them grow and learn as they take the material into their own hands. And the facilitator can take a varying role on this activity. If the students have done a compare and contrast before, for instance, the facilitator can take a more on the side approach, watching them, observing them, and helping them answer any kind of troubling thoughts or questions they may have. But if the students haven't done a compare and contrast before, that's when the facilitator can step in and do what we call modeling. Modeling can help get your students' expectations right, to understand what you're looking for and what kind of success it is. So for instance, if I had a claw of an Allosaurus, I can say, I observe on this fossil that it's curved, it's sharp, and it's thin. Because of the shape, I think that this is a claw because sharp teeth are usually more straight and conical. Boom. A nice, great example of modeling. I can even have the students already give me their observations. I don't even have to say my own observations. I can pull from their observations and can make an inference from it. By setting your modeling clear at the beginning, you can expect to have a lot more success and a lot more enjoyable time with your classroom. So let's see the inquiry-based learning in action. And I'm really glad that I did the share my whole entire screen here because I'm going to pop off with this. So hopefully, hopefully that doesn't mess anything up. But back in the 2020 to 2021 school year, we at the Museum on the Move team, we made the tough decision to go virtual. Instead of visiting the classrooms, we would instead have virtual classrooms. We would project from one of the labs in the museum to a classroom from somewhere in Utah and interact with them. One of our principles in the Museum on the Move program is to deliver high quality specimens that the students can observe, that maybe they won't be able to get a chance to observe in the first place. And so when I was creating my virtual class on fossils, I wanted to make something special. And at this time, I was getting into something called photogrammetry, which I'm sure some of you have heard before. It's the process of you taking photographs of an object from all different angles, and you have a software make a 3D model of that object. So cut to me in the museum, and it's July, early August of 2020. And I'm trying all sorts of objects, also all sorts of ideas to make for this virtual class. And I came across this cast of a baby mammoth. And as soon as I saw this baby mammoth, the light bulb just kind of flicked on in my head. And the ideas of what I can do for this baby mammoth were pretty amazing. I was pretty excited about this. So I created a 3D model of this baby mammoth. And if you were to follow the link, it will take you to this. And students could then observe the 3D model of this baby mammoth through either their home or in their own laptop at school. I have a nice big one overall for the skeleton and a nice big one for a close-up of the skull. So what does this look like in action? So first, for our inquiry learning-based process, I have the students ask questions. Mainly, it's a mystery fossil. They have no idea that it's a baby mammoth. So I established early on, what is it? We have no idea what this is. We are going to take the role of a paleontology detectives and try to understand what it could be based on our observations. During this process, we can understand other questions that can help elucidate that overall idea. Like, what was its lifestyle? Who are its relatives? So I pose these open-ended questions, these questions that students can take into their own hands and do the research for. That leads to the next step, investigate. And honestly, this took up most of the time here. So first, they would write down different structures that they observed on the body. And then later, they would compare and contrast the mystery fossil structures to modern animals. And I would provide these slides to them, like which of these skulls is the most similar? Which is the foot is the most similar? Which of these can we eliminate? Which of these do you think we can keep? And that's the big thing that I want to emphasize. For this investigate step, you don't have to bring your own computers, research papers, books. You can provide your own diagrams, your own items for the students to observe and learn along the way. So they're taking all this into account to help them narrow in on that big overall idea. What is it? Who are its relatives? And what do they eat? Or what was its lifestyle? Which leads me to my next point, the create section. The creating part can be anything from writing a sentence, drawing, diagramming, or just simply speaking your thoughts in a new matter, taking what you observe to what you infer. So I have a student that may say, I think this mystery fossil is an herbivore because I observe flat, rigid teeth. Excellent. They use the evidence on hand to help back it up. That's what I say to my students a lot. Don't just share me with the ideas without any teeth to it. Literally, I guess in this case. Give me the evidence. What do you observe? Sometimes they may say something that may not be what we think is the truth. A lot of times I have students say, I observe the large hole is goggle shaped. So I think it could be the eyes. And in this case, I don't put down the students, or I don't say you're wrong. I say that's interesting. Let's listen to other people's ideas and see if we can, if we agree with that. Which leads to that next step, that's sharing. Through either pair sharing, you have the students talking to each other in the side or in the small groups, or through class polling, we can have students communicate and share their ideas. This creates an environment where everyone's voices is equal and they are being heard. And so the idea of the eyes, the big goggle-shaped hole, which is the nose, but if some students think that they're eyes, we can have listen to other students, and if they compare it to the elephant skull, they say, well, I'm observing similar structures on the elephant skull. Perhaps that's something like that. And sometimes they may have trouble sharing their ideas. And so sometimes I may give a softball question, like try to convince me it's not the vulture skull. What do you observe that doesn't quite look like it? From there, they can start building up and start thinking of more complicated thoughts. And in the end, they can reflect. The students, one of the things I have for a big goal for this activity is reflect how their ideas have changed over time. The nose hole is a great example of that. But a lot of times students may say like, well, you know, this fossil is the size of a dog. I'm thinking it's a dog. And then I have other students say, well, you know, I'm observing something else. When we see those flat teeth, those don't seem very carnivorous to me. And so having those students think of those ideas, go, yeah, I see that, put them aside and be willing to take up new ideas is that process of paleontology, something that is ingrained in the history of it. And something else that I also like to talk about is that, you know, we have the full skeleton here, but imagine trying to deduce its identity from just one bone, because it's very rare, incredibly rare, to be able to accurately reflect on what kind of animal it is, because it's very rare to get that full skeleton. Now, for you yourself, 3D models aren't just limited to that one baby mammoth. More and more museums are taking the approach of cataloging and uploading 3D models of their specimens online. The Idaho Museum of Natural History, great example of that. They have a lot of different skulls and fossils of animals from the past that you can easily take free of charge and do a nice little activity based on it. I love the 3D models because it's a way for students to virtually interact with items that may be breakable, may be unwieldy, or may be rare. And so in this case, this takes that 3D model to them in person, which I find amazing. But what about in-person classes? 3D models are great, especially, unfortunately, now, because of COVID cases are spiking. But in a safer environment, how can we approach this inquiry-based learning in an in-person environment? So first, I want you to think about your on-hand fossils, either in your personal collection, the museum collection, the exhibits. What kind of investigations can you create from them? And in this case, I encourage you all to think open-ended questions for the students. Simple yes or no, black or white questions, I find really kind of abruptly stops that learning process. Like if they answer yes, all right, I don't need to do anything else, let's move on, not much room for debate. Designing an open-ended question can really allow ideas to form. Starting with that basic, what is it? It's fine. If I gave a bone to a student, say, what is it? They can probably give their best guess and that's it. Not a lot of meaning that we can take away from this, which is why it's also good to, after the students have an understanding what it could be, they can follow it up with other more deeper questions. How old is it? What did it look like? What was its habitat? Who are its relatives? How did it live? And in this case, they are really putting themselves into the mind of a paleontologist. They have the fossil on hand, yes, but now it's time to think even deeper, think open-ended of the world's past. So let me give you a few examples of some in-person classes that you can do. The first one that I actually started doing recently is something that I call Dinosaur Investigation. So students investigate a series of casts that come from the same dinosaur. And what they're doing is they're trying to figure out what dinosaur it is. I give them images of different dinosaurs, of their skeletons and sizes overall, and I have them work together as a group to try to figure out its identity. The images would look something like this. You have a kid for scale next to, in this case, an Allosaurus with a close-up of its skull. So we get 4 of these images here. And so I ask them, what body part do you think they're holding? In this case, I give them a rib, I give them part of the tail, I give them a claw, I give them part of a jaw, and I give them part of the backbone. So I ask them, what body part do you think it is and what dinosaur it is? And this is amazing. I love this activity because the students are listening to each other. There's a lot of things to take into account. So maybe one kid is in charge of one of the bones and they compare it to all the dinosaurs, or maybe another kid is in charge of just one dinosaur and he goes through each of them. And there's a lot of excellent debate that goes on in here, especially for the identity of some of the bones themselves. I hear a lot of times, like, they pick up the rib and they go, this is part of the tail. And that's where you, as a facilitator, can come in. You can come in and say, well, I look at this, and when I look at the tail, I observe many different bones. Does this bone here, which is long and thin, does it look like it's made of many bones? And the kids would say, no, it doesn't really look like it. And I go, yeah. So, but is there a bone in here that you're seeing that could match that description, something that's long and thin? So that's an example of how you as a facilitator can come in and help them orient themselves back on the right path. Really fun. I love this one. I love them all. I love all fossils, but I love the process of having the students be paleontology detectives to go from point A to point C is just, I just get a kick out of it. Another example you can do is classify. Trilobites, super common. Brachiopods, common. Ammonites, crinoids. The invertebrate fossils that we have are numerous. You can easily do a classify activity with them. And you can give them a whole bunch of these different fossils and tell them, sort these out. Tell me which of these you think belong in which group, and what shared traits or characteristics do you observe. And you can even push it a little bit further if you want. Like, for instance, the trilobites. I have on hand a cast of a sea scorpion. And so I give the students a whole bunch of trilobites, and then I say, okay, I got this mystery fossil right here. I want you to think about this. Do you think that this is a trilobite or not a trilobite based on what you observed earlier? And so then they compare all the trilobites and compare it to the sea scorpion. And most of the time I get a resounding no, it's not, because I observed the tail or observed these pincers and so forth. So you can really start pushing them into start thinking about these similarities on hand. And even more so, you can bring it to the present. Give them fossils of organisms whose relatives are still alive today. Plants, great example of this. And something that will actually come back a little bit later too. Observe the structures, observe the features, and think about what has changed and what has remained stable over time. And the final example that I would give, though there's plenty of others, is habitat. Give students a variety of fossils from the same formation, have them deduce what this habitat was like. And they can even draw a model of this ancient habitat too. What I really like about this is that crinoids. I love crinoids. I'm actually from the state of Kansas, and I have fond memories biking beside road cuts and just going up to the limestone and just seeing all these crinoids. I had no idea what crinoids were when I was young, but I didn't know what clams looked like. I didn't know what coral looked like. And so when I see a crinoid, I know that this rock was deposited in an ocean at some time, because I usually see crinoids with clams and coral. That is an example of how you can draw in fossils that students may not know otherwise, but then draw an overall picture of this ancient environment. Here's here's the thing, though, is that oceans are a bit overdone, in my opinion. There's nothing wrong with doing a reconstruction of an ancient ocean, but I feel that we in Utah can get especially juicy and get a little bit creative. As a little bit background, I love Lagerstätten. I love all those beautiful fossil sites in the world. And we got some really amazing Lagerstätten here in Utah, such as Green River Formation. As mentioned earlier, I used to be a park ranger at Fossil Butte National Monument, which protects a little bit of the Green River Formation. From there, I fell in love with this. And I think that this formation is a fantastic example of what you can do in the classroom to help students reconstruct an ancient habitat. First, the fossils are inexpensive. Cnidia is like the most common vertebrate in the entire world. You can get these herring for a dime a dozen. And with that, you can get fossils of plant leaves, for instance. Casts. A lot of the casts from the Green River Formation are available online, like the running bird, the bats, and turtles. And you can provide images of larger fossils like palm fronds and the alligator. And you can provide them to students all at once and have them think about what was this habitat like. And what's great about this activity is that, students, they see a trilobite, they see an ammonite, they understand this as a creature from a long ago. But when they observe the Cnidia, they go, that's a fish. When they observe a bird, they go, that's a bird. These are animals and plants that are recognizable still today. And having that process, I think, is great because you can have this amazing juxtaposition from the dry, colder climate of Utah today to that in the past. And it's not just limited to the habitat. You can do all sorts of amazing activities with the Green River Formation. You can design a food web, have them think about how these animals interacted with each other. I love this example right here. I think it's like one of my favorite fossils in the visitor center is a fossil of a leaf with insect damage on it. That in itself tells me so much about what this world was like from this one fossil alone. And doing that comparison, like you see here, can really push those students further. Like, maybe they're not seeing any insect fossils, but we're seeing insect traces, these trace fossils here, which make me think that something similar was living back then. So you can do all sorts of great activities. Design a food web. Infer why some fossils are more common than others, like why we're seeing a whole bunch of fish, not a lot of land mammals. You can talk about climate change. You can talk about preservation methods. Why are we seeing a whole bunch of beautiful leaves and stingrays, and other places, other fossil sites don't really do that? You can really hone in on the importance of plants too. I feel like that plants just get the short end of the stick in terms of paleontology, in terms of research, and also in terms of education, because utilizing plants and reconstructing ecosystems is so important. And the Green River Formation has that by the thousands. So really leaning into that concentrat and conservat of that Lagerstadt in here. Okay, so where to start? So the Utah Science Standards are based on this national principles of three-dimensional learning. And it's these ideas of trying to apply consistent scientific, rigmarole, cross-cutting concepts, and so forth into the educational system. Really putting that inquiry-based learning to the forefront. It's divided up into three sections. Core ideas is based on the overall topics, like Earth and space science, biology, and the physical sciences. Cross-cutting concepts are concepts that we see happen again and again throughout the different deciphers. So stability and change. In biology, our bodies are constantly in equilibrium. When there's something that we ingest or there's an influx of a certain chemical, our body reacts to that and makes sure the chemical is at a more reasonable level. On the flip side, you can have stability and change in nature. A tree changes gradually over time, having leaves, flowers, fruits, and losing them. But it's still the same kind of tree, and it's still going to grow the same kind of fruits and leaves over time. And then there's practices. How do scientists actually study the world around them, study these phenomena? They can analyze, interpret data, or they can argue from evidence, as just a few examples from here. But these standards are used inside the Utah Science Standards. So I highly recommend you to check them out. These are just a few examples that I give here. But using this terminology, which is, like I said, consistent throughout the grade levels, will already make your program fit into what children are already familiar with. Very specifically for the fourth grade standards, their focus is on animals, habitats, and fossils. And for both of them, they are as follows. Analyze and interpret data from fossils to provide evidence of the stability and change in organisms and environments from long ago. Emphasize using the structures of fossils to make inferences about ancient organisms. And 4.1.4, engage in argument from evidence based on patterns in rock layers and fossils found in those layers to support an explanation that environments have changed over time. Emphasize the relationship between fossils and past environments. A lot of the activities that I gave you, or as an example, already fit into these concepts. And so here is the mind-blowing part, and probably going to be the most controversial part of this presentation. You don't have to worry about casts or molds. You don't have to talk about time periods. You don't have to focus on the names of organisms. And you don't have to focus on the anatomical body parts. That is not what's important here. What's important is the process of learning. How do scientists go about learning the past? Saying to a kid that this ammonite or this trilobite is from the Devonian, they're going to be like, cool. So what? But having the kid understand that these trilobites are found in this layer and observe plant fossils from a layer above it, they're understanding that from these two layers alone, that the environment is changing. It goes from an aquatic to a terrestrial environment. Time periods are fine. If they're inquisitive, you can say like, well, it's from the Cretaceous period, which was during the end of dinosaurs.
I have to write it down.
But for the most part, focusing on that process of learning is going to be more important. Okay. So preparation, things to keep in mind. Message. What is the overall idea you want your students to take away?
All right, I'll ask her to.
In this case, paleontologists group organisms based on shared structures. Supplies. What fossils do you have on hand or can easily obtain to deliver that message? In this case, I have a ton of trilobites, so I can do an activity for students to compare and contrast trilobite structures. Audience. What background knowledge should the audience know before starting the activity? My students don't know what a trilobite is, so I'll give a 5-minute rundown of them before they begin the activity. And success. What does success look like? Students will be able to communicate at least 3 structures that unite trilobites along with 3 structures that separate them. So think about that as you're designing your classes and your activities. Here's some things to be prepared for. Failure. Go big and fail hard. If something doesn't play out, that's okay. Approach it differently. I hear so often from so many educators who are like, I'm worried about it not succeeding. I'm worried about it just not going well. Here's the thing. If you have the enthusiasm for it, that's already 90% of the way there. And you can just roll with it. Something doesn't work out, that's okay. You can try again a little bit later. The audience. Audiences are different. And no matter, even if you're giving the same presentation 100 times to 100 different classrooms, each of those presentations is going to be unique and different from each other. Certain messages or certain approaches may resonate stronger with them. One class may be familiar with the topic, another is not. And also students, kids, they're like us, we're different. They may express themselves through talking, writing, drawing, diagramming. Trying to pigeonhole students to do one thing and do it the exact way of doing that can potentially limit their creativity, their understanding and appreciation of the topic on hand. Be prepared for time management. Be flexible. So if you have 5 things you want to say but are short on time, pick 3 to focus on. If you have plenty of time, add an extra 2 things. And supplies breaking. If you're talking to kids, if you're interacting with kids, it is guaranteed that fossils will break over time. It is just the way it is, and that's okay. That's what glue is for. And here's the thing too, is that if you have a particularly fragile fossil, You can put it in a little box with a little glass lid on it. And the big thing, though, is don't go down hard on the student if something were to break. I would break things all the time as I was a kid. Being understanding about it helps alleviate the situation. Also, I should say, be prepared for technology. That should be a 5th point on here, as evidenced by today's presentation. Technology can be funny, and sometimes situations that go right the first time around, if you do everything the exact same time, second time, can go whack. So I'll put technology as an unofficial 5th if you're doing virtual. Lastly, have fun. You are creating a new generation of paleontology detectives to inspire them to not learn through watching a TV, listening to an expert, or reading a book, but taking the material on hand and going through it. Something that I want to really hone in is sometimes kids have this idea that you need to have a degree to be a scientist. And I disagree tremendously with that. If you go through the process of learning, observing, analyzing, talking, and creating new ideas, that is a scientist. When I was a kid and I would see fossils of that crinoid, I would understand that this particular layer of rocks was an ocean. I did all that in the process through my own observing and discovery. Anyone can be a scientist. Lay the foundation of critical thinking and listening to their peers. Something that I really strive for is that we should be willing to disregard our old ideas when the evidence no longer supports it, and be willing to take in new ideas. And sometimes those new ideas may be coming from our peers. So be willing to listen to your peers. And then finally, inspire them to apply their knowledge outside of the classroom, not just for paleontology, but other subjects as well. That's why I like the inquiry-based learning. It's flexible. You can use a lot of different ideas and topics to really tackle these big overall questions. And again, to reiterate, have fun. I have a blast doing this. I love seeing the kids learn. I love being with them, and I love being stumped by them, and I love seeing them grow. It's just like you have a flower, you plant it, you water it, you tend to it, and seeing it grow is it's the equivalent that I would say to that. With that said, if you like what I have to say, I have a Twitter account. It's called Fossil Bonanza. I love Lagerstätten, like I said. So I post nothing but facts and articles and images on there. So if you're interested, check that out. And if you want to do a more in-depth look into Lagerstätten of the world, I made a little map for this. I have over 150 sites with images and links and descriptions. So if you have like a group of high schoolers or even college students, you can have them like research their own Lagerstätten. This might be like a great like stepping point forward to learn more about the world around us. With that said, thank you very much. I am sorry for the tumultuous technology issues there.